data mining, data exploratory data analysis, and data analytics with respect to the fraud analytics. So we are going to get into details of it, but the reason we want to show this as the first slide is in future, if any of this participant group is interested in any one of these topics, then we can get into that specific topic in detail. For today's session, it is going to be high level where we cover all aspects, but it will not be too much into the details because the second half of the presentation, Aparna is going to get into the details of fraud analytics. So all these topics are going to be at a high level. That being said, like, what is data analytics? Data analytics by itself cannot be separated out from data engineering. So data analytics is going to be a byproduct of data engineering where we set up a business requirement, we work through that business requirement to achieve a specific target. So the target can be specific to fraud analytics, it could be specific to marketing campaign, it could be specific to any of the other different use cases. And this can go beyond one sector. So right now we are targeting financial industry, but this can go beyond one sector. So whatever we see as concepts for data analytics is not going to be restricted just for financial sector. It can be for any sector. And the extension of data analytics is artificial intelligence. Right now, we see that there are more enhanced way of doing analytics, and artificial intelligence is one of those concepts where it is an extension of data analytics, but to more of an automated fashion. So it helps you define what kind of attributes you want to use for solving any use case. For example, right now we see like 16 to 20 different participants on this call. So if in future, if we want to extend this beyond this 20 participants, we have to do some kind of target analysis, and that feature selection is going to drive our campaign or targeted audience. So artificial intelligence is automating this process and enhancing this process for feature selection. Data mining, again, is a concept where we try to polish the data to an extent where it can be used for any data use case. And it can be for, like, when we talk about data mining, we can prep the data to define any data product, or it could be a business product, or it could be any of the outputs of the data itself. And fraud analytics and detection is going to be all these concepts, whatever we spoke in the first four bullet. Fraud analytics and fraud detection is going to be an extension of whatever we do as part of the data prep exercise. And if anyone has any kind of questions, feel free to make it more interactive. You don't have to wait for the last. You can ask your questions then and there, and happy to answer. So in financial industry, what is the purpose of fraud analytics in financial industry? So when we talk about financial industry, it could mean a bank, which is a consumer bank. It could be a wealth and asset management client. It could be any of the financial sector. It could be an audit processing company. So all these financial sector related organizations, they have a competitive landscape. So right now, like, there is like multiple banks available to serve globally. And when we have to expand the operations of a financial organization, it comes with a lot of competition. And if the data, whatever is being processed and managed by the financial organization, is not well protected and governed, then it is going to lead to a point where they will lose out on the competition. So competitive landscape gives rise for the financial institutions to build their data platform in such a way that they are able to sustain their competition. Customer profiling. So again, based on whatever we saw, right, in place of 20 participants, we have to enhance and improve this to 200 participants. Customer profiling, here we call it customer profiling because it is financial industry related. So customer profiling is to target the list of customer base and see what campaign, if provided in the market, is going to help the customers, like, bring acquire more customers. So there is a specific concept of customer acquisition It can be acquiring customer to a retail product. It could be a customer being acquired for a credit card product or any other products. So the bank usually comes with multiple products, and customer profiling is one of the key areas which needs to be targeted and governed so that we can expand the customer base. And this customer base or customer profiling is all sector agnostic, so it is not limited to financial industry. AI driven selection, so this is something which I covered previously. So if you look at financial industry, there are going to be 300 plus attributes or 500 plus attributes which needs to be like verified, profiled, and then what attribute is going to make sense for a specific use case is the key decision making aspect. So if we want to be very precise with our feature selection, AI driven selection is going to support the industry to make that feature selection more accurate and more efficient. Decision support system. So when we talk about again any organization, decision support is one of the key aspects. So we have to build a framework, and the framework needs to extrapolate across multiple departments so that whatever decision we make is going to be useful across multiple departments. It's not going to be limited to one specific department. If we take, for example, if we take an university, the university needs to make a decision across all departments for few of the criterias, and they also will have to do a decision specific to one specific department. So they should have a way to target their methodologies in such a way that it is able to provide a decision for multiple use cases and versatile. Like the decision engine needs to be versatile. Yeah. With respect to now we are actually getting into the financial industry specific details. So when we talk about the major pillars of any data driven decisions, there are like three primary pillars which we see: data intake and consumption, data privacy and governance, and scalability challenges. So when we talk about data intake and consumption, so the technology has continued to evolve. So when we initially started, we would have spoken about, like, even when we do any kind of research, we talk about mainframes, we talk about Photon, we talk about COBOL. Like all these were like now legacy systems. We no longer use it. Mainframe is still continued to be used to some extent, but we are moving more towards cloud computing. And even with respect to the extract, transform, or load ETL processes, we used to have data stage, we used to have Informatica, but now everything is moving towards cloud computing based services where it is becoming more real time. It is no longer batch job or batch process. So there used to be a phase like early 2000 where it was all batch process. When we talk about batch process, we actually look at 1 day old data. It's not real time. So when we look at the data, like the banking system used to be like at least 1 day 1 day old data. So if you do a payment or a deposit today, you will be able to see that data on the backend systems only tomorrow. So that's how it used to be, but that is no longer the case right now. All data transactions are being real time. If there is going to be a fraud analytics which needs to be happening, it is also real time. So the real time data processing is coming into the forefront, and it is also a game changer for any industry. Even for healthcare, like any real time, like whatever we see as like smartwatch, smart ring, anything relating to smart devices, those are all like real time feeds. And those are like probably like in the last 10-15 years, that's when like the smart watches, smart devices came into the picture, and that's when real time ingestion came into the picture. So when it comes to data privacy and data governance, every bank is governed by a compliance policy. So it could be state regulated, it could be country regulated, it could be global regulated. So we have a lot of regulations which comes into the picture if there is going to be a banking system in place or a financial system in place. So the reason for that is when it comes to global trade, the money is going to be traded, and the money could be traded in any form. It could be in US dollars, it could be in Sri Lankan rupees, it could be in Indian rupees, it could be pounds. So there are going to be multiple ways on how we do the money trading, and it is important that when the trading happens, it goes through a regulatory compliance framework. And this framework is really important to stay compliant with any of the government regulated policies. And data governance is I would say, is a blanket umbrella on top of compliance. So any regulations or compliance is implemented with the support of a governance policy in place. The governance policy could be different for different organizations, but governance policy is what defines how we are going to implement a government or a state government regulated compliance framework. So scalability, again, like this is something which I touched upon previously. So scalability, previously we used to have like legacy systems where you keep adding server whenever there is a need. So sometimes there have been situations where the server runs out of memory. So we have to add an additional server. That's how it used to be in the past. With the cloud computing coming into the picture, it is no longer the case. We have auto scale up, scale down options where whenever there is a peak time or whenever there is a festivity which is going on, the number of transactions is going to be more, then we scale up the server. And whenever it is going to go down, we reduce the number of servers. So the clusters are spun up real time and it is closed as and when it is not needed. I will stop here if there are any questions before I move on to the next slide. Okay. Yeah, any question, Shankar?
Google Trump question. Actually, we got a few questions based on your slides, just
Okay.
from the participants. Yes.
Sure.
So
Yeah, we
how
can go through.
I'll read the question, so then you can provide your answer. How does government policies influence implementing some systems related to fraud detection?
Yeah. So in terms of regulators, right? The regulators are going to have a specific kind of rules in place. For example, if I, as a person, if I am supposed to be transacting only a certain value per day, that is the max which comes into the picture. So when we talk about rules and government policies, it is really important to note that government actually goes through a lot of different changes, like globally based on the type of global or the geopolitical environment. There are going to be government rules, and to answer this question directly, there are going to be limitations irrespective of wherever we are banking from. It could be in any country, any state. So a state can mandate that a person can transact only, like assuming 10 lakh Sri Lankan, uh, I don't know the actual currency, but Sri Lankan rupees per day. And if there is a transaction for an individual which goes beyond the 10 lakh, then the bank has to raise an alert and the bank should stop it. If that rule is not in place, the bank is going to allow the person to do the transaction. They are answerable to the government. When those transaction gets audited, they are answerable to the government. Even though the bank operates separately, like as a private entity, all transaction which happens through the bank, irrespective of whether it is like government sponsored bank or a private bank, all those transaction gets audited and the bank is answerable to the government. And all these are going to be in place irrespective of wherever we are located. So that's something which governs the policy of how we do a banking system. Hey Shankar, I think you're on mute. Shankar, I think you're on mute.
Thank you, Gokul Ram, for that wonderful explanation. We got another one more question related with the financial services, especially related with the banks. So
Mhm.
the question is, are the OTPs sent by banks or any other service providers masked in SMSE when it's reaching a particular end user?
Good question. I think it depends from vendor to vendor. So the bank
Yes,
actually
because
works. Yeah.
in Sri Lanka, actually, we have many telco service providers. So when we are doing any transaction for a bank, when the bank sends a OTP through their operators, right? So it comes
Correct.
from the SMSC of that particular telco operator. So it's
Correct.
generated as an A to P message, application generated message, and it should reach the peer. So in that
Correct.
case, is there any regulation to mask that particular OTP? Because even someone who is working in as a systems engineer in SMSC side, even they might, if they log into the particular server, they may able to see that, right? So the question was related to that actually.
Yeah, so just to answer that, the banks will have multiple, like they will have multiple vendors to choose from, and there is something called encryption over transfer. So when we talk about encryption, uh, right now, like even in WhatsApp, if you look at when you go to settings, it says that the message is encrypted. So it's the same way when it comes to OTP. If the telecom operator has an encryption policy in place, usually the banks work with the telecom providers to understand the encryption policies before they go for a specific framework. So for any OTP related things, it is going to be encrypted at the origin, and it is also going to be encrypted till the point it reaches the person. Only at the time reaches the person, it is decrypted. So it has an algorithm within it to have an encryption when the message is going, like message is being transferred over the channel. So it's like similar to what we do for email, right? Email, when we look at the way email is being channelized, it has an encryption policy in place. So when the email is being sent from one person to other person, the medium in which it is being channelized, those are going to be encrypted. Only after it gets delivered, it is decrypted. So that's like automated already. So the same policy works for the OTP as well. But that is not government regulated. It is up to the bank on how they want to encrypt and decrypt.
Okay. Thank you, Gokul
Yeah.
Ram. And we have one more question related to the
Yeah.
banks after that you explained. So considering some of the Sri Lankan banks and even some of the websites, the users observe some websites doesn't require kind of OTP to do the bank transaction. So even if someone provides the credit card details, then the CVC number, immediately the transaction is done without getting an OTP. So how can end users protect themselves from those kind of websites if they want to purchase something using that
I
website?
think I have gone through, yeah, I've gone through the same thing. So if you look at the website, right, it is going to be either HTTP or HTTPS. So if we are getting into a website, the first thing which we need to check is HTTP. If it is HTTP, then we definitely should not provide our credit card details or bank details as part of our transactions, because HTTP is an open protocol. Like it's not like secured protocol. That's why we have HTTPS. So for any banking related transaction, HTTPS needs to be really verified. And if it is HTTPS, we have to make sure if it is having some kind of history in place, because right now everyone is having the ability to purchase a domain. So they can purchase a domain with HTTPS website. And then if the domain is like opened yesterday and they are doing a transaction today, it's probably a potential fraud or a scam. So when we do it, I think there are like online ways on how we have to check if a website is legitimate or not. If the website is not legitimate, then it's better we don't even get into those websites for doing any transaction. So I personally have been like I've gone through that experience where I shared my credit card. The next day, my credit card was used somewhere else. So I had to cancel all my transactions, like get back my credit card with a different number. So all those happened. So it's quite obvious that we are going to get into that kind of a place. But now I think the systems are more matured. So we also should grow with the system, because there are multiple ways. Like when Aparna is going to touch upon the types of fraud, you are going to see like what are all the different types of fraud. And one of the common ways of a fraud to happen is there could be a WhatsApp message with a link, or an actual text message with a link. You go and click on that link, you're almost compromising on your privacy. So you're giving extra information for them and they can hack your mobile phone. So we have to be very careful on what link we are clicking. And if we should not be clicking some link, we should not do it. That's how we should get away from all these fraud related options.
Thank you, Gokul for that wonderful explanation about the difference between HTTP and HTTPS and how we can identify the safe websites. Uh,
Sure.
Thank you,
Sure.
Gokul. So those are the questions that we had up to now.
Okay. Okay.
Yes. Over
Yeah.
to
Moving
you.
on to the yeah. Thank you. Moving on to the next important thing, right? So right now, like initially it was like more complicated. Like when we add our legacy systems, there is a lot of thought put towards the architecture. But right now, with cloud computing coming into the picture, the architecture has simplified. The internal technical details, it continues to evolve again, but the architectural principles again have got simplified. Whatever we see on the screen, this is not just for fraud detection, but it's for every, like almost every industry can probably take the same architecture and they can start implementing their technical capabilities. So when we talk about medallion architecture, so this is quite common across all computing operators, irrespective of whether it is Amazon cloud or Google or Microsoft Azure. The architecture still remains the same. The way the services are being provided to us varies depending on what we need. So when we talk about medallion architecture, leaving the source and the consumption is left to the industry itself. But bronze, silver, and gold, that's how usually the architecture is in the cloud computing platform. When we talk about bronze, it is for raw data. When we say raw data, it is the data which is as it is. There has not been any transformation. There has not been any data wrangling or data curation. It is an as it is data where even if we get a wrong data, we still have that data as part of the bronze layer. And silver is the layer where we actually have it as cleaned and curated. So when we say cleaned and enriched, we look at the raw data, we transform the data to make it align to the specific data warehousing principles, and we make sure whatever aggregation we should do to support any downstream consumption, we can try to support it as part of silver without applying the business filters or the rules. When we talk about gold layer is the one where we actually have the implementation of any data science algorithms or any of the other algorithms which is needed for supporting the banking system. So looking at bronze layer, so I've listed like data cleaning, data validation, standardization, and deduplication. So it is a place where you start to get the raw data as it is, and you can start applying these principles before you move the data onto silver, which is the clean layer. And when we talk about the silver layer or the cleaned layer, we talk about data enrichment, because when we look at any data science exercise, there is something called imputed values. For example, if we have a boolean value of yes or no, and we have one and zeros, we have true or false. All these are like multiple ways of defining a data value. And as part of silver layer, when we do the data enrichment, depending on the data science team, we should work with the data science stakeholders to define like what imputed values the data science team needs. Mostly the data science algorithms work based on one and zeros. So imputed values is going to be where we apply all those data transformation to make it data science eligible or data science ready. And in gold layer, we can perform whatever algorithms we want to perform to kind of do what is required for the actual data science exercise itself. So a data science exercise could mean predictive analytics, where we predict this is going to be the outcome, so let us provide this campaign to a specific customer, or it could be a fraud detection. And consumption is like consuming the data which has already been prepped and which is already ready and it's available for use. Yep. So when we talk about all these architectures, most of us would have heard about big data adoption or big data as a concept. So when we talk about big data, this is where I was mentioning about early 2000 or like 15, 20 years ago. So big data used to be a buzzword back in like 2005, 2008 when Yahoo started building out Hadoop MapReduce. So whatever we see as mainframe is a older system of big data. So mainframe is popular for holding like big datas, but the only challenge with mainframe is it is expensive. It does a lot of data volumes, but it is all going to be batch process and it is going to be slow. When we say slow, it became slow starting like in the 2000s. Like no one wanted to really wait for like 5 days for a batch process to complete before they can start using the data. So that was the challenge with mainframes. And when we moved into big data era, like big data started becoming more popular because it was able to do distributed computing at a faster pace. So whatever was executing in mainframe for like 5 to 10 days will usually complete in big data within a day itself or within like few hours itself. So that's the advantage of big data. And I'm not going to get into the building blocks of the data warehousing because in the interest of time. But when you look at big data gave way for data mining, big data gave way for data science, big data gave way for like machine learning and data visualization. So all of these were like made more optimized and efficient by the uh, introduction of big data into the ecosystem. Yeah, this is like when we say big data landscape, this also applies to cloud computing. So these are all the different aspects of big data and cloud computing. So data lake. So what is a data lake? Like bringing in a data to a centralized location and sourcing the data from that centralized location. That's going to be data lake. What this does in terms of advantage is when an organization is going through any kind of data modernization effect or efforts, they will be able to source the data from a centralized location, and that centralized location is going to be governed by data policies, governed by data compliance, implementations, data quality. All those are already assumed to be applied in the data, whatever is available in the data lake. So data warehouse, again, once the data is available in the data lake, we have to build some kind of data product, and this data warehouse is going to help us do that data product. Hadoop distributed file system, as I mentioned, like this came into prominence in the 2000, 2005, 2008 timeframe when Yahoo started building Hadoop MapReduce. They add a storage concept called distributed file system. So here we call it Hadoop distributed file system, but this applies for any distributed file system. So the data is distributed wherein it's not centrally located in one place, but it's distributed in multiple areas, and the data is fetched in an efficient manner. Kafka is like like this used to be called like messaging queue in the past. Messaging queue is like a publisher subscriber model, but message queue used to be like with limited bandwidth. So when we talk about Kafka works in a distributed pattern where it can feed the data in a faster way, in an optimized and efficient way. Data processing, again, we moved from batch processing to more of like real-time processing, and all these have evolved over a time. And data replication is again one of the key principles of cloud computing and big data. So when we say data replication, in the past, whenever there is a server which goes down, when it goes down, we lose the data. If we don't copy the data periodically, if we don't take backup of the data periodically. So this used to be a manual process where there is a database administrator who logs into the system, who takes like continuous data backups to keep the data actively available, even if the server goes down. With cloud computing and big data, this data replication happens automatically. So we define how much replication we need, and we specify one as the master node, one as the child node or the secondary node. So whenever there is a data which is going into the master node, the same time with limited latency, it also goes into the secondary node. So if the primary node falls or if it goes down, the secondary node automatically takes over. So it's the concept called high availability, and data replication is one of the key principles to make the high availability available. So let me go. Any questions at this point, Shankarnath, like which I can answer before I move on?
So far, we have not got any questions from the audience. Uh, if anyone has got any questions, you can unmute yourself and ask.
And if you have worked on the same concepts, go ahead and feel free to share your experience as well.
Yes.
Okay. So let me move on to the next slide.
Yes, go around. Yes.
Yeah. So analytics on large data sets. So when we talk about big data, so we spoke about big data adoption, we spoke about big data landscape. So the next important concept is the analytics on large data sets. So big data, like just to give some idea, big data, when we talk about big data, we are talking about like millions and billions of data. We are not talking about hundreds and thousands of data. It's all in millions and billions. So analytics on large data set, again, uh, like participants who have already gone used who have had experience or exposure to SaaS does like the same thing. It also can process like large data set, but the amount of time it takes to process the large data set is considerably more. So it's similar to mainframe, right? So it SaaS takes like 5-6 days for a process to complete and fetch the results. When we talk about analytics on large data set, this can get you the results within minutes. So that's the important aspect of analytics on large data set. And how does it uh, improve the efficiency? It is going to give better resources to execute the logic and get us the results. That is one important thing. It also gives you the result in an optimized fashion, wherein if you execute the same logic again and again, it's not going to re-execute. Rather, we have caching mechanism in place where the intermediate results is stored in the cache. So whenever we re-execute the same logic, it's going to get the data from the cache rather than re-executing it. So if you know that you are going to execute the same logic multiple times in a day, if you run that process early in the morning, then for the entire day, you are going to see like faster or optimized performance. So if a process takes 30 minutes, you execute it like in the morning before business hours, the entire day you are going to get the results within like 1 or 2 minutes because it has already got the results in the cache. It's not going to re-execute. And this is also going to like this concept is also important for the fraud detection because fraud detection needs to happen real time. So assume that you have your credit card uh, information shared on one website and the transaction is going to happen, and if it is going to be a fraudulent transaction, this analytics on large data set is going to influence on how the fraud can be detected because it is going to be real time. The data is going to be like hit on the server, and based on some rules it is going to fetch you the results immediately. So it's really important to go through that process, and analytics is going to be one of the key factors because that governs our business rules. Yeah, data governance, I have probably touched upon this in detail. So with data governance comes like accountability, like there is going to be some communication in place where one sector or one department within an organization share what governance principles they are going to apply on the data, and they send it across to cross functional teams so everyone is aware like what is going to be the expectation. Documentation of the rules, whatever has been implemented, master data or reference data, data quality, and data privacy. So I will skip on this because like I want like enough time for the fraud use case itself. So data quality, again, it has like multiple like principles of how we implement data quality. accuracy, completeness, consistency, timeliness, and validity. So when we talk about accuracy, it is more about accuracy of the data itself, like whether it is defined to a business requirement and it is implemented to a business requirement. So just to give an example, if my name is expected to be shown as Gokul Ram Krishnan, that accuracy needs to be in place. Because if you look at any of the systems, in some places it could be reflected as G Krishnan, in few places it could be Gokul Ram K. So what accuracy defines is the definition of how we want to see the data as part of the system. Completeness is, again, like if there is going to be a mandatory field, the field needs to be populated with yes or no. We should expect yes or no. There should not be any nulls, or it should not have any empty characters. All those needs to be taken. Consistency is more about the data being available. So if I expect that the data needs to be loaded once every 10 minutes, it should be loaded once every 10 minutes. That shows the consistency. And a timeliness is to again keep the data fresh for any use case. And validity is going to be any archival mechanisms, data types, data formats, all those needs to be accounted. So if a data needs to be in CSV, I should not get a data in Excel. It should be CSV. If a data needs to be in text format, it should be in text format. Those goes into the validity. And the flow diagram at the bottom is how a data quality happens. So we gather requirements. A data analyst or a data steward writes the rule on what needs to be implemented. Then as an organization, we sit together, understand like what tool we can procure for implementing the data quality rule. It could be an vendor tool, or it could be an internal development itself, in-house development. And once those rules are like drafted, it can be reviewed and it needs to be understood from the logical aspect. Then we implement the rule, we create a dashboard, some kind of dashboard to define the metrics, followed by deploying the rule. So these are the multiple aspects of data quality. And when I talk about decision framework, this closely aligns to what we already covered. When we talk about data landscape, we are going to have data mining, we are going to have data science models, we are going to have multiple decision rules. All those are going to come into the aspects. So whatever we see on the right side, it is going to like drive how we do data science exercise. And this data science exercise is what is going to be the final outcome of fraud detection and prevention both. This needs to be like implemented in such a way that we are able to do it. And if you look at it, machine learning is not a separate concept, it's within artificial intelligence itself. Like artificial intelligence cannot be separated out from machine learning because both go hand in hand. And machine learning is going to be a subset of artificial intelligence with respect to the overall implementation pattern. And when I touched upon the medallion architecture, I touched upon few of these, but in terms of a life cycle, this is how a life cycle happens. So when it comes to fraud detection and prevention, that is going to be like we have to identify the right data source. We have to prepare the data in such a way that we are able to understand whether it's a real fraud, it's a false alarm, if it is a positive alarm. Like all those comes into the picture based on what we use as the data and how we prepare the data. If we don't prepare the data properly, then we cannot even identify whether it's a false or not, a false alarm or a true alarm. Train and develop the model. This is a continuous process because like we have to train the model in such a way that we are aligning it to a specific use case. Validate the model for performance. When we do validation of the model for a performance, we usually align it to a existing data set. So we usually take an history of data for the last like few months or last few years to understand what kind of frauds are already happened. Because as I said, training a model for fraud prevention or detection is very difficult because we don't have that level of data volume for training the model. So we have to look back at least like few years to get the actual fraud. And when we have to deploy the model, the key aspect is ongoing performance monitoring. This is going to be the key aspect because when Aparna is going to touch upon the types of fraud, this ongoing performance monitoring is what is going to define how we are evolving our model, how we are keeping track of the fraud which is happening. So today, a fraud can happen using one one mechanism, tomorrow it's not going to be the same. It could be different mechanism. Today they are going to send you a link where you click on the link, a fraud could happen. Tomorrow it could be a different situation. It could be a attachment. Even now we have attachments where it says like you are expected to pay so much dollars. So it could be different patterns. So ongoing performance monitoring is important to keep your model evolving. With this, I will hand over to Aparna for the remaining topics.
Hey, thank you, Gokul. That was really enlightening. So, moving on. So, for the AI this is the rules based engine and model. So now let's take a closer look at like how we leverage both the rule-based engine and the machine learning models to detect anomalies in our system. So first we begin with the rule-based engine. So this approach encodes domain knowledge using if then logic. Like for example, we might flag a transaction if it's over, let's just say $10,000, and it is coming from a new device. So whenever a transaction is being made from a new device, at least I have experienced this like personally also, that I just go and do like $500 transaction and immediately my bank will raise uh, a flag like asking me or sending me a message or an email, hey, is it really you who's doing the transaction at this point for so and so amount. So this method is actually highly effective for identifying the clear cut and the known patterns and for the quick implementation of expert knowledge. Next, we incorporate the machine learning models into it, so which learns the patterns from the historical data. So these models, they help us detect these complex or previously unseen behaviors that were not known to us, or that is like very time consuming process of seeing and determining a pattern if that exists from a large amount of historical data. So we use a variety of models here, including logistic regression, random forest, XGBoost, and even neural networks. And each model brings its own unique strength to our decision capabilities and improving our adaptability over time. So there is like no, I would say, right answer. If somebody comes and asks me, okay, just give me like one model which can solve my problem. No, it is requirement based. It is problem based. So each of my model is going to solve one piece of a problem at a time, and we sew together different models to get that framework which actually does the end to end job for us. And the best is always to go with the hybrid approach, where where the real power lies. So we combine the rules of this straightforward deterministic case and the models for for the deterministic case, the rule based, and the models for more the probabilistic decisions, I would say. So when we layer these together, so we get a strong defense mechanism enhancing which actually enhances both our precision and recall, making this entire system more robust against the evolving threats. And of course, there are challenges, and one of the key challenge is balancing the false positives and the false negatives. So we want to catch real threats without overwhelming the systems or users with unnecessary alerts. But additionally, like both are like rules and the models, they require even continuous training, retraining, I would say, and updates, so that it just stays relevant in this rapidly changing environment. So those are the two key challenges when we talk about rule based engine and the models. Next slide, Gokul, please. Okay, so the industry definition of fraud, what I call it. So, fraud is basically defined as an intentional act of deception that results in financial or personal gain. It involves the manipulation of information or concealment of facts to mislead individuals or organizations. And fraud, it has like certain key characteristics to it. The first one is the intentionality. So fraud is always a deliberate act, meaning the perpetrator has the intent to deceive. I cannot say that, hey, I committed fraud unknowingly. No, who's doing it knows that they are committing that a fraud. It is never uh, an act which does not have an intentionality behind it. The second is the deception. So it involves misleading information or false representation that influence the decision of others. So that's one aspect. The third is the financial gain. So what is the ultimate goal? The ultimate goal of fraud is to achieve an unlawful, I would say, financial benefit, whether for the fraudster or a third party. This is especially with the financial services that I'm talking about. So there are like different kind of frauds. One is like the consumer fraud. The consumer fraud is targeting individuals through scams that exploit their trust or lack of knowledge. This is the same thing that Gokul was mentioning. Somebody just sends you a random email saying, hey, we are from Amazon, and you know what, you just won yourself 1 year of free subscription, or you have won something that you can buy worth XYZ amount of free stuff for XYZ amount of money, but here is the link that you have to click and purchase. So that's like consumer fraud. The second is going to be the corporate fraud. So that involves the the deceptive practices within the organization, such as the financial statement fraud or insider trading. The third is the cyber security fraud, which is very prevalent, and it's always evolving. The fraudsters are using all kind of advanced techniques now to gain to commit the act of fraud. Uh, so what the financial in so the financial institution, or basically the entire financial services industry, we are a heavily regulated domain, and we are required to report any fraudulent activities to the to the regulatory bodies. And two of the main is going to be the SEC, which is the Securities and Exchange Commission, and the second one is FINRA. So FINRA stands for Financial Industry Regulatory Authority. So these are the two main governing watchdogs, I would say, that regulate the financial services industry. Next slide. Okay, so the type of frauds. So, when I talk about the type of fraud, this is again pertaining to the financial services. So, here you can see that we have the credit card fraud, and this occurs when someone uses another person's credit card and information without authorization. So it can happen through various means, such as, like just say, the data breaches happen, or phishing scams, where fraudsters trick the individuals into providing their credit card details. And this is the same thing which Gokul was mentioning. And as per one of the questions, that there is a new website without much legitimacy to it. And what happens if I go and enter my credit card details into it? So there is a high possibility that the fraudsters have your credit card details, and now they can use that details for the for committing the fraud. And that's one of the ways. Or it can happen that I go to a shop, and it has happened like, I just went to a petrol pump, I paid my with my credit card. It was a remote area, and the POS machine actually had a skimmer to it, which made a copy of my credit card. And the next day I see that my credit card was used for Disney, for XYZ. And then I had to call my credit card company and saying, no, this is not the transactions that I have made. And it looks like that my credit card has been skimmed. So the second is the mortgage fraud. So it involves the misrepresentation on mortgage applications, and this can include inflating the income or using the fake documents to secure a loan. So this is one of the most common frauds that happens. The third is the insurance fraud. So this type of fraud basically involves providing either false information to obtain the insurance benefits. And again, the common example include staging an accident or inflating the claim. There are many people who just go and uh, intentionally dash their car and say, hey, you know what, I met with an accident and I am claiming for the insurance. They do it on intention, or they stage it to look like that there was an accident to claim that insurance money, which is one of the most common and difficult type of fraud to detect given the nature of it. The fourth is going to be the identity theft, where criminals actually steal personal information to impersonate someone else for their financial gains. And this can lead to unauthorized transactions and significant damage to the victim's credit or the credit history. Next slide. Okay, so here comes which are the most common type of uh, uh, common techniques that the fraudsters use to exploit the individuals and organization. So let's just start with the phishing scams. So these are like among the most widespread form of fraud. Here, the attackers send email or messages that appear to come from a trusted sources like bank, the service providers, or even co-workers. So, with the goal here is of tricking the recipients into sharing sensitive information such as password or credit card numbers. uh, these messages often create a sense of urgency to prompt a quick and unthinking responses. So I don't know if anyone of you might have got an email saying like, "Hey, it's urgent. Like, I need the money." The fraudster seem to send the email maybe from your friend's account, let's just say, who would have got hacked, and you would have thought like, oh, my friend is asking for some kind of a help. And you would have done it without thinking that is it really my friend who's asking, or what's happening. So that is a phishing scam. So next is social engineering. So this method targets human psychology, I say. So rather than exploiting the system vulnerability, here the fraudsters manipulate people into willingly giving up the confidential information. And this can include impersonating authority figures, exploiting trust, or using emotional triggers like fear or sympathy. Another major technique is account takeovers. So here the attackers gain unauthorized access to the user's account, and they often through their stolen and it is often through their stolen credentials, and they use it to steal funds or gather more personal data. So account takeover is very common, let's just say, for uh, other than the financial industry. It is going to be like my Facebook got hacked or my Instagram account got hacked. So now it is not in my control, but the the fraudster would have done that not to steal funds but to gather like more personal data. So once they are inside, they may change the account setting or uh, make some kind of fraudulent transactions before the account takeover uh, fraud is like detected. So, and then finally, we have the fake websites and apps where the fraudsters create a convincing replica of the legitimate platforms to trick the users into entering their credentials or the payment details. So, these counterfeit interfaces are often distributed through phishing links or malicious ads, and they can be hard to distinguish from the real thing without a very close inspection. So, what can people do? They can just stay educated with all these frauds and always pay close attention before clicking on any of those malicious link or making any kind of a transaction on the platform that they do not trust or it's comparatively like very new. Next slide. So, coming to what is going to be the impact of the all these undetected fraud. So, starting with the most immediate consequence would be the financial loss. So, undetected fraud can lead to significant direct losses for both individuals and organizations. So, beyond the stolen funds, there are additional costs such as legal fees, fraud recovery process, and even potential regulatory fines that compound the financial burden. The second is the reputational damage. A single fraud incident can severely harm an organization's credibility and brand image. Once the customer, uh, once the customer trust is lost, it's extremely difficult to regain it. So this kind of negative publicity can impact partnerships, customer retentions, and market confidence. Then there is operational disruptions. So fraud events often divert resources and attention from the regular business operations. Teams may have to like pause their work to investigate incidents, implement new controls, and report the findings, which impact the overall productivity. The next can be like the regulatory consequences. They are also like of a very serious nature. So failure to detect or prevent fraud can lead to regulatory penalties, increased scrutiny, and the requirement to implement costly compliance programs. So organizations may also face stricter audits or loose industry certifications. So these are some of the impacts of undetected fraud. So I'll just take a pause and see if there are like any questions at this time that I can answer before moving on.
We have a few questions, Aparna, related with the topics that you discussed. So before moving on, shall we
Yeah, yeah,
discuss on few questions? Okay.
yeah, sure, sure.
Is it possible? Is it possible for internet service product providers to detect fake websites immediately once they are hosted?
It might be very difficult to detect it at the very first instance, but I would not say it is like as a highly impossible thing. But again, like as I mentioned, that fraudsters are very uh, intelligent these days, and they create the replica of the websites with so much accuracy that it really uh, takes an attention to detail to say that no, this website is fraud. It's not the legitimate website, and I should not be doing any transaction, or I should not be sharing any personal details on it. So I would say the nuances would be like to see the URL. So maybe, an alphabet might be just interchanged, or adding of an additional letter, which usually we do not pay an attention to it so easily. Like by the time that fraud has already happened, we would have realized, oh, this does not look right, that there was something wrong in this. So not it might not happen immediately, but maybe let's just say a couple of days to few days, the provider would detect it. But I would not say it is impossible to do it, depending upon how smart the you can implement any kind of a tracking mechanism to it.
And just to add to what Aparna mentioned, I don't think like it will be the Ethernet provider's responsibility to block the website, because they are
Yes.
going to pay for the domain, and they are going to do like business, but not all of their business are going to be legitimate. So that's where, as a customer, it is our responsibility to see that we are doing the payment through a proper reputed website than through a scammed website. Because the Ethernet provider, right, they have their own business. So identifying, so there are like opportunities now. Look, if you look at the Ethernet providers, they have a specific subscription plan called theft and identity subscription. So if you engage with them on those subscription plans, they will uh, identify the fraud, and then they are going to tell you that it's a fraud, don't do it. But if you don't have that subscription, their business is not to identify a fraudulent website and block it, because that's not part of their contract, right? So they are not going to block it for you.
Thank you, Gobal Ram, for that interesting answer. And we have another question also related with this section. With account takeover on the rise, how are you moving beyond basic MFA with solutions like Microsoft Intra to enforce risk-based passwordless access? It's in the chat
So
actually.
this is like very interesting. So account takeovers is again a very tricky thing in the financial services. So let's just say if my account is getting account, as in like I'm talking about the bank account here. So if somebody has to hack a bank account, then they should be knowing all the details, like what is my password, what is going to be my account number. They should be knowing what is going to be the answers to the security questions that I might have set while uh, creating my account or setting up my account. Then even there is MFA. So it is becoming difficult for the account takeover to happen, but I would say it is not. There is a section of a society, let's just say, this is especially targeted towards the senior citizens who might not be that tech savvy, or let's just say it's just like, hey, you know what, my grandson just called that, I want to do some I'm not getting my pension check and I gave my account details to check. Now those are the people who fall prey for the account takeover, rather than uh, the people who are more in who are like more tech savvy and who are more aware of the fraud that happens. I have my MFA enabled, but my parents, no, they do not. They do not have this kind of MFA or anything super fancy onto their account enabled. And I usually tell them that, hey, do not share anything, any sensitive information. If somebody is impersonating something and trying to call you that, you know what, you have some check which is not getting cleared, so can you just share your bank account number and the password, we are calling from so and so bank, from so and so account, from the branch, sorry. So they might give it out. There is no stopping for it, as long as, I would say, the awareness is the only thing that can stop, along with having more robust features, like the MFA, having like more security added to it. Gokul, feel free to add it on the account takeovers.
I think you covered it pretty much well. So
Yes, Aparna. Even the digital divide that prevails in the society also influences a lot, because in some societies there is digital divide, especially among the senior citizens. So we observe so many fraudulent transactions happen with the financial transaction, especially with if when they are not aware. This happens in countries like uh, India
It
or
can
Sri
happen
Lanka.
anywhere. It can
Yeah,
happen
yeah, yeah.
anywhere. Like it can happen in any of the countries.
Yes.
no, I can tell you an actual fact, right? I went to Apple Store here. I had an issue with my phone. So I had to go to Apple Store. I saw a senior citizen. He was just giving his password verbally, like in front of me. There are like multiple peoples in that table, and he was verbally giving out his password. He was trying to come there for a replacement of his device, and he was giving his password openly. So, see, like the senior citizens probably like they are not going to have like full literacy on the tech environment. So under like assuming that there is going to be one fraudster in that Apple store, and if he listens to the password, then he can very well get access to the person's Apple account, and with the Apple account he can log into any of those apps if the senior citizen did not set up any of the passwords for protection. So it's quite easy like that way, like even uh, sharing password verbally or in a written form is going to be a challenge, or it's going to create a challenge for you in terms of maintaining your privacy.
Okay, so let's just move on in the interest of time. Okay, so what would be the some of the preventative measures? The first is the robust security protocols, which form the foundation of the fraud prevention. So this includes advanced tools such as data encryption, firewall, and most importantly, the multi-factor authentication. And these security layers make it harder for attackers to gain access to sensitive information, even if one layer is breached. The next is the regular monitoring. So, fraud doesn't usually announce itself, it hides in patterns and anomalies. So, by continuously monitoring the accounts and transactions in real time, the organizations can detect suspicious activities early. So, this could include unusual spending patterns, IP address mismatches, or multiple failed login attempts, all considered as early warning signs that something isn't right. So, equally important is the customer education, which I was talking about. So many fraud attempts succeed not because of the weak technology, but because of the uninformed users. So, educating customers about phishing emails, fake websites, password safety, they can drastically reduce risk. So, simple awareness can prevent someone from clicking on those malicious links or giving away their credentials. Finally, the collaboration with the authorities is the key. So, fraud is rarely isolated, it's part of a wider criminal ecosystem. So, working with the law enforcement and the regulatory bodies would allow for faster reporting, better threat intelligence sharing, and coordinated responses to the emerging fraud tactics. And it also helps organizations stay compliant with the evolving regulations and industry standards. Next slide. Okay, so why AI or uh, AI in the fraud? So why AI? So fraud patterns are constantly evolving, and AI excels at detecting new and subtle anomalies that traditional methods might miss, and it also scales efficiently with increasing data volume and complexity, which is critical in modern financial systems. So, just on a very high level to break it down, so the key AI techniques we use here, and I won't go in depth, is the anomaly detection. So we apply models like autoencoders, isolation forest, and local outlier factor to detect any unusual behaviors or deviations from the norm. And these are particularly useful for uncovering the rare or emerging fraud tactics. The next is the behavioral analytics. So, using sequence modeling approaches such as LSTM and transformers, uh, we analyze basically the user's behavior over time and identifying suspicious sequence of of actions that can indicate fraudulent intent. The third is the graph analysis. So this is particularly effective for detecting fraud rings by analyzing the relationship in the transactional data. So we can uncover hidden networks of collusion using advanced network analysis technique. And these are also applied to the real world scenario that we just discussed. It is credit card fraud detection, where real time response is very critical, insurance claim fraud, where identifying the fabricated or exaggerated claims is of the utmost importance. Synthetic identity fraud, where fake identities are created like using the blend of real and fictitious information. And always there are challenges associated with it. One major issue is the model explainability, where we need to ensure that both business team and the regulators can understand why certain transactions were flagged. And another is the lack of the labeled ground truth data, which makes the training the supervised model difficult. And finally, there is the issue of the time scoring latency. So AI models, they need to provide results quickly without compromising the accuracy. So, next slide. Yeah. So do we have any questions at this time?
And the last point in this slide, which talks about or last 2 points, labeling ground truth data and real-time scoring latency. This is something which is really critical for any industry. So when we talk about labeling ground truth for fraudulent transactions or fraudulent data, we usually don't have the actual training data. So as I mentioned, it could be 1 in million or 1 in 100 million. So you will not have a data on which you can train. So you have to mimic the data in such a way that you are able to build that data for training purpose and real-time scoring latency. So like if you look at the software industry, we have had multiple rules engine in place. So real-time scoring latency was never possible before, like probably 5 6 years ago, where everything goes through a batch process and then the fraudulent transaction gets identified later on. But with real-time scoring latency, it is making it easier for the industry to analyze the risk and the fraud and is able to immediately raise it as a fraud. So that real-time scoring latency is one of the key differentiators which would allow us to do like fraud prevention. I think we can open for questions.
Thank you, Gokul Ram, for that explanation. And we have one more question in the chat box. Difference between Hadoop and Spark. Simple question.
Uh, yeah, so when it comes to Hadoop, right? So Hadoop now is being called as like outdated because Hadoop also is little slow. So the way the Hadoop distributed file system and the Hadoop ecosystem works, it is considered to be little slow. When it comes to Spark is more advanced in terms of how the DAG works. So it works based on a DAG. So the processing and the compute power of Spark is making it more easier for users to use. And there are multiple ways a Spark can be used. It can be used as a Scala code. It can be used as a Python code. It can be used as a PySpark, which is combination of Spark capabilities with Python coding. It can also be done as a SQL. So it is coming in different flavors, which is not to be the case with Hadoop. Hadoop used to come with Hadoop MapReduce, which used to be a Java code. So the time you need to cross-train and onboard to Spark is comparatively less compared to Hadoop. And Hadoop is no longer going to be the go-to technology. Hadoop is going to be a backend technology which is going to support Spark execution.
Now we have come to the end of our webinar today.